So here we go again with my newest video, which is always true when I make the video. Rainbows don't weigh much. They're actually pretty light. Well, good morning or good afternoon. It is so good to see you today. Today we're going to talk about the imaginary number or the imaginary unit, the letter I, or for my electrical engineering folk, the letter J. So I want to start today with just a quick little story. This video is just about what is the imaginary number, like what the hell is this thing we're supposed to learn? And I want to just talk to you a little bit, like when I was in high school, I remember, and I was in high school a long time ago, I remember being in a math class and being almost angry that my teacher was teaching me about the imaginary unit, and for me also logs. I thought those were the two most useless things anyone had ever endeavored to teach me. And I held that belief. I went to college, right? I started doing legal studies, then I started doing electrical engineering. Started taking these electrical engineering classes, right? Open up that textbook, first page, second page, third page, I'm looking through them. That imaginary unit, that letter I, is all over that textbook. I'm like, holy crap, this is like really important. Like, and that's one of the things I want to tell you, even before I explain what it is. It matters, it's important. It might not be important to you, but it is important. And I think when I was a kid, or that you ain't kids, but when I was a teenager, if I at least knew that it was important, I probably would have focused better on it. So it is important, trust me. It might not be important at the grocery store, but it does matter. And it's also really interesting. So let's now talk about it. At the end of the day, the imaginary unit is the square root of -1. That's what it is. That's all it is. It's a symbol. If we were, if we endeavored to just write the square root of -1 a bunch, we wouldn't need I. It's just a symbol because it's a lot faster than writing that. And the fact that it exists, the fact that mathematics has even bothered to switch to a letter must mean it must be super important. All right, so let's talk a little bit about it. Number one, it's not a real number. The word imaginary, it's a name. It's not a good name, but it's a name. But it's important to at least know that it's not a real number. It ain't on the real number line. That line that you know that has all the numbers you've ever seen. It's got all the integers, it's got all the decimals and the fractions, all the numbers, all the irrational numbers. The imaginary number is not on that line. You're not going to find it on that line because it's a totally different number system, which is a crazy concept. It's like, hey, welcome to Math 2. We're going to do all these quadratic stuff, and then all of a sudden, boom, whole new number system. So bear with me. You're not going to need to learn all the details about it, but just keep in mind that that's a big deal, right? It's a whole new number system. And if you think about it, think about how crazy negative numbers were to people before they learned about that system, right? Like, just imagine, let's take 3 minus 4. Now you go back to the early days, right? But when numbers were just like objects, right? 3 was 3 of something. This wouldn't have made any sense to anybody. Like, think about this. It's like saying you have 3 apples. You have 3 apples and you want to take away 4 apples. How many apples do you have? Like, that doesn't make sense to anybody back in the day, right? I'm talking thousands of years ago, but still, like, you can't take 4 apples from 3 apples. There's no solution. There would be no solution to that. But see, now we know that there are these things called negative numbers, right? So now we would say, oh, well, it's -1 apple. I mean, what the hell is that, really, right? But so what you're going to see with the imaginary unit is the same kind of conundrum that people probably thought when they first started to experience negative numbers. I mean, just imagine, what if this part of the number line just didn't exist to you yet? Like, you didn't know about negative numbers, and someone's like, what's 3 minus 4? Well, let's figure it out. I'm going to go over 3. 1, 2, 3. That's 3. Now I got to go backwards 4. 1, 2, 3. Oh, where the hell are you, right? Like, where did you go? There's nothing back there. And then at some point we realize, oh, it keeps going the other direction. And so you actually land quite comfortably at -1. And what I want you to learn in this unit is you're gonna land quite comfortably with imaginary numbers. All right, you ready? They're important. I promise you that, they're important. So, let us imagine something then. Imagine if when you learned, let me erase some of this. When you learn about negative numbers, right? So let's say your first time you saw a number like -5. That how we were taught about that is that negative is a 180-degree rotation on the real number line. I should write that, right? Because this is the real number line. So what you do, if you're thinking about -5, is you go out to 5 and you rotate it 180 degrees. Now you're over here and you're at -5. So negative numbers are a 180-degree rotation on the real number line, all right? So we know that seems, that doesn't take a lot of convincing. But now think about this. Here's what's interesting. What if, instead of going up, come on, Miller, make a better degree symbol. Come on, Miller, what are you doing, huh? Okay, imagine if we rotated 90 degrees. Where would you be? Are you visualizing that? Like, where are you? You ain't at the beach, right? I mean, where are you? If you just rotated, you'd be like up here, right? You'd have this line, and now it's going to here. It's not on the real number line. You're up there somewhere. Like, here's your little number. Now it's way up there. Where are you? Well, it doesn't matter where you are, but you got to follow this. If you were to do that again, you have to be back on the real number line in the negative, right? So there has to be a mathematical operator that shifts 90, and if you multiply that one again, you're shifted back to the negative number system. That is why this representation of I is probably the best to figure out what's happening here. That I squared, because this shifting, that's a multiplication symbol, not the letter X. This multiplication by I shifts you into what is called the, I'll go back to black. I'm gonna go back to black here. What's actually called the imaginary axis, right? So you shift, you're up here, you're no longer on the real number axis. And then if you do that again, you're here at a negative, which is why I squared is actually that multiplication by -1. So therefore, I is the square root of -1. So, in conclusion, right, this is a big deal. It's a big mathematical deal, and I hope you appreciate that. It is important. Euler's formula is, I don't know, most important formula in electrical engineering. I don't know, maybe. Close. Top 3. Look it up if you want some more insight, but yeah, so, I don't know, in retrospect, the purpose of this video is for me to communicate to you that it matters. Because when I was learning it, I didn't think it mattered. And it might not matter to you, but I think it's important to at least know that it is an important concept. And it's actually really beautiful. That's quite interesting. And I hope you enjoy it. All right. Well, it's been good talking to you. I hope life's treating you well. And I hope to see you around someday. All right. We're done. Okay, so I got to do a quick little cut in. I never do this, but there was a point I forgot to make in the video, which was in the same way that 3 minus 4 wouldn't make any sense to somebody, say, 2,000 years ago, like without negative numbers. This is what you're going to be confronted with, which is where are the x-intercepts of that parabola? Like, when does that parabola cross the x-axis? Well, it never crosses the x-axis, right? not in the real number system. So like, you need imaginary numbers to make sense of where that crosses the x-axis. Just like back in the day, they needed negative numbers to make sense of what 3 minus 4 is.